All right, let's dive right in. Today we're talking about a technology that is seriously shaking up the energy world. It's not flashy, it's not glamorous, but it is incredibly powerful. And honestly, it might just be the key to unlocking a cleaner, more stable energy grid for all of us.
So let me just start with this question. What if the solution to one of our biggest energy problems wasn't some rare, super expensive material, but was actually something you have sitting in your kitchen cabinet right now? It sounds almost too simple to be true, but that's the whole revolutionary idea behind the sodium-ion battery.
So to really get why sodium is getting all this attention, we first have to look at the current king of the hill, lithium-ion. I mean, it's everywhere, right? It's in your phone, your laptop, in pretty much every EV. But, even a champion starts to show some cracks after a while. And here's where the problems are popping up. It's not just that lithium is getting crazy expensive. It's also that the world's supply is concentrated in just a handful of places, which creates these really fragile, really complicated supply chains. At the exact same time, our need for huge grid-scale energy storage is just exploding. Lithium is fantastic, don't get me wrong, but it just can't be the only solution for everything.
And this is where our new contender makes its grand entrance. The sodium-ion battery, or SiB for short, is stepping up to fill some of those gaps that lithium is leaving open. And its secret weapon? It's built from one of the most common, cheapest elements on the entire planet.
And that right there is its superpower. Sodium is in seawater, it's in rock salt, it's literally everywhere. That makes it dirt cheap and gets rid of all those tricky geopolitical supply chain headaches. When you're talking about powering something as massive as a city's energy grid, well, that's a total game changer.
Okay, so how does this thing actually work? Let's do a quick breakdown of the parts. First up, you've got the anode. The easiest way to think about this is like the battery's waiting room. When you're charging the battery, this is where all the sodium ions go to hang out and store up that energy. And on the other side, you've got the cathode. This is like home base for the sodium ions. When you charge it, the cathode sends the ions on a journey over to the anode, and when you use the battery, it welcomes them right back home.
Now, the thing connecting these two is the electrolyte. You can think of it as the superhighway that lets all those sodium ions travel back and forth. Without this highway, the whole system would just grind to a halt.
And this is the truly brilliant part. We're not reinventing the wheel here. The basic design is almost exactly the same as a lithium-ion battery. We've just swapped out the star player, and that makes developing and manufacturing these things so much simpler.
Okay, so we've met the team. Now let's get into the play-by-play. How does this simple setup actually create and deliver the power we need?
So, when you plug it into charge, you're basically forcing the sodium ions to leave their home in the cathode. They travel across that electrolyte highway and pack themselves into the anode's waiting room. They just sit there, holding onto that electrical charge until you need it. Then, the moment you connect it to something, the whole process flips. The sodium ions are naturally drawn back home to the cathode. This big migration creates a flow of electrons through the circuit, and that flow, well, that's electricity. That's what powers your stuff. And that's really the whole secret. It's just a constant reversible dance of sodium ions moving from one side to the other. It's this beautiful, simple cycle of storing and then releasing energy, all driven by basic chemistry.
All right, it's time for the main event. We know how it works, but how does our challenger really stack up against the reigning champ? Let's go head-to-head and see the tale of the tape.
In sodium's corner, you've got some serious knockout punches. For one, it's way cheaper. It's also more sustainable, and importantly, it's safer. It's just less likely to overheat and cause fires. But its biggest advantage, its real haymaker, is that it's absolutely perfect for grid-scale storage, hoarding massive amounts of power from solar and wind farms.
This quote just nails it, doesn't it? Lithium is amazing at cramming a ton of power into a tiny space, like your phone. Sodium is built for the exact opposite, packing a truly massive amount of power into a really big space, like a power station.
But of course, no challenger is perfect. Sodium's big trade-off is something called energy density. Because sodium ions are physically bigger and heavier than lithium ions, you just can't pack as much energy into the same amount of space. This makes it a tough sell for things that need to be super light and powerful, like a top-of-the-line electric car.
And this table really gives us the final scorecard. Look, the most important thing to see here is that best use row. This isn't about one being flat out better than the other. It's about having the right tool for the right job. Sodium wins on cost and availability for big stationary storage, while lithium still crushes it on energy density for our gadgets and high-end EVs.
So what does this all mean for us right now in 2025?
Why is this tech suddenly leaping out of the research labs and into the real world? Let's get to the final verdict.
Well, it's basically a perfect storm. Our demand for grid storage is skyrocketing at the exact moment that everyone's getting worried about lithium prices and supply. That has triggered a flood of investment, and now we're seeing the first big commercial projects go live, both in power grids and even in some more affordable EVs. The timing's just perfect.
So the final verdict isn't that sodium is here to deliver a knockout blow to lithium. Not at all. It's about coexistence. The future of energy is going to need a whole team of different players, and sodium-ion has absolutely proven it's ready to be a star player on that team, handling the big, heavy-lifting jobs that lithium was never really designed for in the first place.
And that's really what you should take away from all this. Lithium will probably keep running our gadgets for a long time, but sodium is getting ready to power our world. The next time you flip a light switch, the clean energy behind it might just be coming from a battery whose main ingredient is as simple and as common as table salt.